In this video, we're talking about how to use elimination to solve a system of linear equations. Remember, there are three methods you can use to solve a system of linear equations: substitution, elimination, and graphing. And in this video, we're going to be talking about elimination. Elimination means we're going to add our equations together or subtract them from one another to eliminate a variable so that we can solve for the other variable and then use that solution for the one variable to find the other variable. So we've been given two examples. Our first system of linear equations is x plus 2y equals 8 and 5x minus 2y equals 4. So what we want to do is be able to add these equations together or subtract them from one another to eliminate a variable. In this case, this one's pretty simple because what we need to notice right away is that we have a positive 2y in the first equation and a negative 2y in the second equation. So if we add these equations together, we're going to get a positive 2y and a negative 2y. Those two things will cancel with one another, leaving us with only the x's. So that's what we want to do. We want to say addition here. We want to add these together. And then when we do that, we're going to get x plus 5x, which is going to give us 6x. We're going to get positive 2y plus a negative 2y, or 2y minus 2y is 0, so those two cancel. And then 8 plus 4 is 12. So notice how we've eliminated the y variable, leaving us with only the x variable. Now we can solve for x. We have 6x equals 12. We want to divide both sides of the equation by 6 so that we get 6 to cancel from the numerator and denominator. So we're just left with x on the left, and we get x equals 12 over 6, or 12 divided by 6 is 2. So now we have the solution x equals 2, and we need to use that to find a value for y. So we'll plug the value x equals 2 back into our first equation to find the associated value of y. So plugging 2 in for x right here, we're going to get 2 plus 2y equals 8. Subtracting 2 from both sides, we get 2y equals 6, and then dividing both sides by 2, we get y equals 3. Now sometimes these problems get a little messy or a little tricky, so once you find your solution, you want to make sure to double check yourself so that you know that you did it right. So we use this first equation here, x plus 2y equals 8, to find the associated value for y. So now we want to take both of these values, x equals 2 and y equals 3, and plug them into this second equation to make sure that the second equation is also satisfied by this solution set. So plugging x equals 2 in for x here, we get 5 times 2, or 10. Plugging y equals 3 in right here for y, we get minus 2 times 3, or minus 6, so minus 6 equals 4. Well, 10 minus 6 is 4, so we get 4 equals 4, and that checks out. So we know that this solution, 2, 3, is a solution to this system of linear equations. Let's do another example here. We have the system 2x minus y equals 13, and 3x plus 4y equals 3. Well, in this case, it's not as simple, because if we add our equations together, we'll get 2x plus 3x is 5x. So if we add, we'll get 5x, negative y plus 4y would be a positive 3y, and 13 plus 3 would be 16. So addition wouldn't eliminate anything. If we did subtraction, we'd get 2x minus 3x, or negative x, y minus 4y, or negative 5y, and 13 minus 3, or 10. So whether we do addition or subtraction, no variable is eliminated, which means we need to do something different. The thing we're going to do differently is manipulate one of these equations so that a variable will be eliminated when we do our addition or subtraction. The easiest way probably to do it is to multiply this first equation by 4, because if we do that, we'll end up with a negative 4y. We have a positive 4y here, so then if we add those equations together, the negative 4y and the positive 4y will cancel with each other, leaving us with only x. Alternatively, we could multiply this first equation by 3 to get 6x here, and the second equation by 2 to get 6x here, and then we could subtract the equations from one another because we'd get 6x minus 6x is 0, and we'd just be left with the y's. So there are multiple ways to go about this, but the easiest way is, again, probably to multiply this first equation here by 4. So let's see what that looks like. When we multiply by 4, we have to distribute the 4 across every single term in the equation on both sides. So 4 times 2x will give us 8x, 4 times a negative y will give us negative 4y, and 4 times 13 is 52. So we've changed that first equation. Let's go ahead and write our second equation underneath it. So 3x plus 4y equals 3. Now we have a negative 4y and a positive 4y. So if we add these two together like this, we'll get 8x plus 3x, which is 11x. We'll get negative 4y plus 4y, or 0. And we'll get 52 plus 3, or 55. Now we can divide both sides of the equation by 11 to get x by itself, and we'll get x is equal to 5. So now with the solution x equals 5, we need to find the associated value of y, and in order to do that, we can go ahead and plug this value, x equals 5, back into our first equation here. When we do that, we're going to get 2 times 5, or 10, minus y equals 13. Subtracting 10 from both sides, we get negative y equals 3. And then multiplying both sides of the equation by negative 1 to solve for y, we get negative y times a negative 1. Those negatives cancel, and we're left with positive y is equal to negative 3. So there's the associated value of y that goes along with the value we found for x. Now we just need to double check to make sure that this solution set satisfies the second equation and not just the first equation. So plugging both of those values into our second equation here, we have 3 times x, but we know x is 5, so we'll get 3 times 5, or 15, plus 4 times y. So we know y is negative 3, so we'll get 4 times negative 3, which is a negative 12, and then we have equals 3. So we'll say 15 minus 12 equals 3. 15 minus 12 is 3. We get 3 equals 3. That checks out, so we know that the solution x equals 5 and y equals negative 3, or 5, negative 3, is in fact a solution to this system of linear equations, and that's how you use elimination to solve a system of linear equations.